And our next speaker is José Hernández, former NASA astronaut and CEO of Tierra Luna Engineering.
First of all, good afternoon, and let me say thank you, and very happy to be here. I just want to say a little bit about my background. I'm a former NASA astronaut, and I flew on the space mission STS-128 aboard Space Shuttle Discovery on as the flight engineer. We were the second to last mission for station complete. What that meant is if you look at the building process of a house, the second to last mission is almost like the people bringing in the appliances, the furniture, the inner workings of the house is what we were bringing in. We brought in 7 tons of equipment utilizing the multi-purpose logistics module Leonardo built by the Italians. And most of that equipment was placed inside of the International Space Station, but some of it was placed outside, including ammonia tank assemblies, some antennas, some cameras, and some cabling for the very last module that was going to be attached. And so we spent 14 days up there doing that work. Now, when they announced the retirement of the space shuttle fleet, you know, the only game in town was going with the Russians on the Proton rocket Soyuz capsule. And it involved a lot of travel to Russia. But since I have 5 kids, I figured, you know, they were reaching their teenage years. So I said, I think I'm going to stay here and leave NASA and just start my own consulting company, which is what I have been doing ever since 2012. So the disclaimer I want to give here, want to make sure that we're very clear, is that the opinions and what I say is definitely not a NASA position. It's basically José Hernández, ex-NASA astronaut position. Nonetheless, I don't think I would say anything controversial that NASA would disagree with. I may make a few subtle, smart remarks, but other than that, I think we're okay. Now, the first thing I want to do is I want to address the elephant in the room, in the sense that, you know, NASA is no longer the only game in town when it comes to sending humans to space. And the private sector has become what I consider a major player now. You know, you see these three companies that I have outlined there, Blue Origin, SpaceX, and Virgin Galactic, but there's others coming. Those aren't going to be the only 3 sending humans up to space. And the initial thought is, well, they're catering to the space tourism market. But I don't think they can be sustainable if they just did that. Because if you look at human transportation systems in the past, when passenger airplanes came online, they came online about 1914. And I'll tell you, a ticket from New York to Florida was very expensive, and it was only for the well-to-do who could travel at the beginning. And what kept these airlines afloat was that they had a government contracts with the US Postal Service to deliver airmail. So while they became a little bit more inexpensive with respect to the manufacturing process of buying planes and of that sort, the US government helped them because they were essentially subsidized by providing this airmail service for the US Post Office. Well, here it's a little bit about the same process that's going on. You know, my comment is, I don't think if these companies were solely to cater to space tourism, I don't think they would survive. And as you can see, there's companies like SpaceX and Blue Origin that already have contracts with NASA to help them with certain aspects of space exploration that they're, and I'll talk a little bit more about that later on. But in a sense, NASA is the U.S. Post Office for these companies trying to develop some type of space tourism or some type of presence, long duration presence in space. And so NASA is helping them accomplish that because they're being subsidized, quite frankly, with the work that they're doing for NASA. And so, you know, what I want to mention is that not all of these companies are created equal in the sense that I don't think they all have the same end game in plan. I think each of them have different end games. Some of them certainly going for the tourist business, but I just have to look at the architecture of these rockets, and I could tell you that for example, Blue Origin and SpaceX are looking into going into space and going into deep space probably, and they've already have a contracts, for example, to help NASA develop the lunar lander, those type of things. So their architecture is pretty much rockets, if you like, you see them there, kind of like NASA and the Apollo Artemis program that I'll talk a little bit about, that goes into space. And so their end game is, you know, access to not just low Earth orbit, but probably going into deeper into space. And I think Elon Musk has made no mistake that he wants to go to Mars and the moon. So that's consistent, and their architecture is consistent. But then you look at the Virgin Galactic architecture, where it's a space plane that, you know, it goes up 40, 50,000 feet, it's released, and then it does its suborbital flight. And it's up there for a few minutes, and then it comes down. Well, I don't think that's an architecture that's going to be sustainable if all they're doing is taking up tourists up there for a few minutes at a time. That's not sustainable. But I do tell you that given that architecture that I'm looking at, I think they're looking at developing some type of suborbital intercontinental travel ability. What am I talking about? Well, you know, if you go to from New York to Singapore, you know, it's going to take you 14, 15 hours to get there in a regular plane. You can imagine one of these bad boys taking off from New York, and in about an hour, you're able to see, you're able to land in Singapore. So you greatly cut the amount of time required to do intercontinental travel by doing suborbital flights. And that's what I think Virgin Galactic is going after. So they're all going after different things, but all of them want access to space, and they're accomplishing it. Now, we've been in low Earth orbit for, I would venture to say, about the past 50 years, you know, ever since Apollo's very last mission, Apollo 17, 1972, when we had the last man be on the surface of the moon, Gene Cernan. We haven't sent humans to the moon since then, and that's almost been 50 years. And so what I'm saying is that that we also have that challenge. The eye on the prize for us right now is not really the moon; it's going to Mars. But how are we going to do that? And I think we first need to take baby steps and be able to solve the problems associated with long duration space travel. And the best way of doing it is in the confines of our home, close to our home. And I'm not saying low Earth orbit, because we've been doing that for the past 30 some odd years kind of thing. I'm thinking more about going to back to the moon. But before you do that, also got to realize that government entities such as NASA and the European Space Agency, the Russian Space Agency, they don't have unlimited funds to say, okay, well, now we're going to start a new program, but we're going to keep the programs that we have right now. I don't think that's sustainable either. So what I'm suggesting is that the International Space Station is probably going to be retired in the near future. It's either going to be given to a private entity so they could operate it and it doesn't cost NASA or international partners additional funds. And why do that? Well, because they're going to move those resources so that they can start working on the next phase of exploration of space beyond low Earth orbit. And again, before we go to the moon, the best strategy is, I mean, before we go to Mars, the best strategy is let's return to the moon, except that this time, you know, we're not gonna go there just to collect rocks and dirt and sand and then come back and analyze. This time we're gonna go there to establish a long duration outpost that then we can address the technical hurdles that need to be solved before we go on into Mars. So we need to solve those problems, and it's better to solve them in the confines of our home. Now, the one thing I wanted to do is just talk a little bit about the brief history of our return to, of us being in the moon, as we're gonna return to the moon. And that is, you look at your history books, those of you that aren't old enough, you know that NASA's Apollo program went on from 1968 to 1972. And during that, it sent 9 missions to the moon, and 6 of which resulted in successfully landing on the moon. And that meant that there were 12 individuals who walked the lunar surface during that era. 1972, as I mentioned, Apollo 17 being the last one, Apollo 11 being the first, and of course, Apollo 13 didn't make it because of the problems it had. So the next chapter of lunar exploration is NASA's Artemis program. And again, you know, can't emphasize the fact that what the whole purpose is, we're gonna establish a long duration lunar base so we can develop the technologies in preparation for what it is a much more complex mission, which is send humans to Mars and be able to bring them back safe and sound. And so the moon is going to be our test bed. In short, what we do on the moon, which is only 250,000 miles away, a three-day trip, we must be able to do on Mars, which could be up to 225 million miles away, and it's a 6-month trip. Best case scenario, 6-month trip using current propulsion technology. And so that's why it's important. The moon, you know, if something doesn't work on the moon, it's easier to get back. Something doesn't work on Mars, man, you can't forget something, or something cannot fail that's critical, because you are very far away from home. And so that's why the strategy is let's develop that lunar base, and let's test out and develop the technologies needed to go to Mars. Now, what does the Artemis mission look like? Well, it has 2 main components for the Artemis system. The first one starts with with Orion, and you see a picture there. And it basically has 3 elements to that. It has a crew module right in the middle, and it can fit 4 to 7 astronauts. Below that, you have what's called the service module. And the service module has the life support system. It also has an engine that gives it propulsion. And then on top of the crew module overlaid is what's called the launch abort system. The launch abort system basically is a system that will be able to extract the crew module at the launch pad in the event of a emergency on the launch pad or shortly after takeoff. It's able to pull it out and take it to safety and then parachute down. It has 3 solid rocket boosters and provides that 40,000 pounds of thrust necessary to extract it out. So that's the Orion system. Then the other part, equally as important, is the space launch system, the SLS system. And if you go from the very top to the very bottom, you'll see that it has a cargo hold that's able to take, I would say, about 40 tons of equipment up into space. It has an exploration upper stage, which gives it some additional thrust as it gets into orbit. And then, of course, the initial thrust is the massive core stage with the engines, and then it's helped out by 2 extended range solid rocket boosters. Extended range as compared to the ones the space shuttle system used to use. And here's a pretty good graphic of what a complete SLS system would look like. And as you can see in the cross section, the core stage consists of 2 tanks of oxygen and hydrogen, and it feeds the engines, and then the 2 side solid rocket boosters that provide the initial thrust for the first couple of minutes or so. And it has a total, the whole system has a total of 10 engines. And, you know, it has 4 of those, the engines, the main engines that look very similar, or are very similar to the space shuttle engines, because they were modified and they give a little bit more thrust to it. And fully weighted down, fully fueled, it weighs more than 6 million pounds. And as I mentioned earlier, it could take up to 40 tons of payload, and getting into space, pretty similar to the space shuttle. It takes a little over 8 minutes to get you up into space. So it's a pretty robust system. You compare it to the Saturn V rocket, it's definitely more powerful than the Saturn V that used to take the astronauts in the Apollo architecture. It's slightly, I think it's only about a foot taller, but it definitely, thrust-wise, is definitely more powerful. And so they're getting this system done. Once you're up in space, you lose that first stage, and the system looks like this. You have another 4 engines. They're RL-10C3 engines that when it gets up there, they fire briefly to put the system Orion in what is called a working orbit, so that it's orbiting around Earth. Once it does that, the astronauts now have the time to reconfigure the spacecraft before they fire the engines again in the exploration upper stage you see pictured there, to leave the Earth orbit and to go on their 3-day mission to the moon. As it starts arriving to the moon, it jettisons the upper stage, and then it starts arriving to the moon. Now here's where things have changed a bit, and quite honestly, I'm not sure, because the requirements keep changing because of, I don't think it's a technical issue. It's more of a political issue. It's more of a timing issue. I know that the original plans for going back to the moon called for the construction and creation of a small station like the International Space Station, but it's called the Lunar Gateway, and it's a pre-stage area, so that when Orion arrives, it's able to dock to the gateway, and waiting for it there is a lunar lander that's attached also to the gateway, and there's other things attached like supplies, those type of things. So the astronauts would get out of Orion. Some of them would climb into the lunar lander. Some of them would stay in the gateway station orbiting the moon, and they would go down, and it would be a reusable lunar lander is the way they envisioned it, and they wanted to design it. And so all that looked great until the previous administration, I think, made an edict saying that NASA shall send astronauts to the moon by 2024. Well, on that time schedule, there was no way NASA was going to be able to get the gateway and pre-stage it and have it ready for the way to operate it the way I just told you. So what they started to work on is towards a plan where they would take gateway would not be in the critical path. In other words, the first missions would be very similar to how Apollo did it, where it would arrive, it would rotate around the moon, and it will already have a lunar lander with it, and it would then go down and to the moon and then come back without a gateway. My hopes is that things have changed again and that they do have a gateway, but quite honestly, Things change so fast at NASA that I don't know what the most recent plan is with respect to Gateway, if we're going with Gateway or we're not going with Gateway. Now, once we get to the moon, what's going to happen? Well, this is very interesting because this is a challenge that the astronauts in the Apollo era didn't face. They only stayed for a few hours and would leave. We want a long duration lunar base there. But there's challenges associated with that because you envision building some type of shelter for the astronauts. And this shelter, you've got to look at how that habitat design is going to be, what materials you're going to use, because you're going to be under a very harsh environment. You're working within the vacuum of space. There's no atmosphere on the moon. There's severe temperature variations between direct sunlight or being cast on the shadow of a structure. You also have to be cognizant of the fact that there's micro meteorite impacts. You have to protect yourself from cosmic radiation. And so it would be impractical for us to say, okay, well, we're just going to take 4-6 feet with cement slabs with us to the moon, because that's too heavy and very impractical to do. Even just the cement bags to take them up there is not practical. So what you want to do is you want to use raw materials on the moon and build from there. You can use regolith material, which is basically crushed rock. And the previous speaker, Dr. Hernández, talked about the fact that there's underground caverns. There's pits that lead to lava tubes, and that may be a natural habitat because it's underground and you're shielded. Other health concerns you have to be aware of is that there's a lot of lunar dust, as astronauts found out when they walked on the moon, that if you ingest into your lungs could be a potential hazard. And then of course you're only at 1/6 the gravity of Earth. So what are the long-term health effects of a reduced gravity environment? We're already learning, past 30 years or so, we've been learning about that on the International Space Station, the US Space Station Lab, and we've been finding ways of mitigating it, like exercise equipment and exercising diligently so that we mitigate the effects of muscular atrophy, the bone density loss. But then you also still have to have the psychological effects of long duration being away from home. So all these things are concerns and that we need to address, and we need to have a plan forward with respect to that. Now, what kind of design concepts are out there? There's, I looked around, there's a lot of design concepts with respect to building habitats on the moon. And one of the things, of course, is location, location, location. As any real estate person will tell you, you got to pick the right location. And of course, one of the concerns is you want to be near natural resources. And one of the resources that's most important is water. And it's been said that they've mapped out quite a bit of craters in the southern pole, where the dark side of the crater seems to contain ice, which may be a nice water source. But in terms of habitats, there's been interesting designs. For example, there's been a design from the European Space Agency where it's a build and fill type of design, where you go into a small crater and you put an inflatable structure, and then you fill it up to the top. You put another inflatable structure on top, and you fill it, and you keep doing it until you have a multi-layer habitat system and covered with natural terrain for the shielding part of it. And so that's a pretty interesting approach. Another approach is a manufacturing approach. I call this lunar 3D printing, because it's almost similar. You take a thin layer of the regolith and you subject it to focused sunlight, and it's a sintering technique where things tend to bond together, in a very thin layer, and then you put some more, and then you build it up. You keep the same process, and you're building it up and building it up until you're able to build interlocking brick structures. You can change the shape of them if you shape it. All these type of things you can do on the moon, but we have to be there to start trying it out and see if that works. And then the thing with this is you probably need about 3 to 4 meter thick brick to shield you from the cosmic radiation if you were to just live on the surface and not go underground. But if you do go underground, you can find underground lava tube structures. And my feeling is that the final habitat is probably going to be a combination of the 3 I just mentioned to you in terms of how they're going to build it. They'll probably select a lava tube that's big enough where they can put structures on it, and then maybe do a build and fill kind of thing as well. But I think that's very very plausible that could occur.
5 minutes
And
left.
Got 5 minutes left.
Yes, and you see that Dr. Hendrik and others in Arizona have built maps where lunar lava tubes exist, and you could have a natural design solution as well. But again, I think it's going to be overcoming it. Now, developing a self-sustaining ecosystem on the moon, the obstacles are pretty clear. I mentioned about the water source. Oxygen is another thing that you need, another element that you need, and you can. There's studies out there of molten regolith electrolysis that releases oxygen. That's pretty interesting too. We must be able to grow our food and produce our own energy. Solar panels. There's material there to build your own solar panels. So in closing, what I'm saying is that when we succeed on the moon, we can set our sights on Mars because the obstacles are very similar to overcome. The only other thing that we need to develop is advanced propulsion systems, aside from the chemical systems, that will get us to the Mars quicker. And the strategy, do we need fielding stations along the way? And how are we going to protect our astronauts along the way from cosmic radiation? You solve those problems and you're almost ready to go to Mars. So we're pretty excited about the future, and I think this is where I end, and we have enough minutes to address several questions. So happy to take them.
Wonderful. Thank you so much, Mr. Hernandez. We do have a couple of questions. The first one is, how are they going to perform suborbital flights in already polluted lower Earth orbit and orbit? Shouldn't they clean it first? Well,
the beauty about low Earth orbit is that things, for example, you take up a CubeSat and you operate it, and in the orbit that it's in, within about 3 months to 6 months, its progression is going to bring it closer and closer to Earth, and it eventually burns down. So the low Earth orbit things tend to clean themselves up pretty good. The ones that don't clean themselves up pretty good are satellites that are 5,000 kilometers away, geostationary satellites. Those guys aren't ever gonna, well, they'll eventually make it back to Earth, but it's gonna be hundreds of thousands of years by the calculations. Those are the ones that we should worry about the most.
Thank you. And there's definitely way more questions that we can answer live, but the last question would be from Miguel. And Miguel is asking, do you consider that international cooperation is needed to reach goals to return to the moon, human exploration, and so on and so forth?
I believe so. Look, anytime a private entity spends $1 on space exploration, that's $1 less Miguel and I have to pay in taxes so that they can give NASA a bigger budget, or another country a bigger budget, in the European Space Agency, Japan, or Russia. So I'm all for private entities exploring space and spending their own money doing so, because we all benefit from it. Now, a lot of people say, having so many problems on Earth, why are we out there in space? Why not solve the problems here on Earth? Well, the money being spent for exploration on space it's being spent in Earth and in good paying jobs. Also, the technologies being developed in space are good for repurposing here on Earth. And that's gonna help us eventually. My hope is that technologies that we work up in space is gonna help us so that we can take better care of our planet with respect to the environment and energy, those type of things that are all an issue here on Earth. By having innovation up in space, we can reapply it here and solve problems, real world problems here on Earth. So that's a great question, Miguel. Thank you.
Wonderful. Thank you so much, Mr. Hernandez.
Thank you.